All right, let's talk about prediction intervals. So once we've built some model, some y hat equals x beta hat, we can calculate predicted y values. And we've been doing this already for each of the individual observations in our data set. For example, you used the fitted function to pull out those predicted values y hat, or you were able to just multiply your x design matrix by beta hat to get those predicted values. But what if you wanted to predict a value on a new observation? So an observation outside of your data set. And that's what we're going to be talking about today. And so for that, I'm denoting that as y hat 0. And so this is some new predicted value for a new future observation or a new set of predictors, x0. So x0 basically represents the predictors for a specific new observation. And so you can get those predicted values, y hat 0, and that's just going to be equal to x0 transpose times beta hat. So for example, if we fit a model y hat equals 1.2 plus 2.5 times x1 plus 3 times x2, this was our model, and we wanted to know the predicted value for someone with a value of x1 of 3 and x2 of 2. What would you do? Well, I think in a previous class, you may have just learned this as you just plug in x1 here for x1, and you plug in x2 here for x2, and then you add up all those components, and you end up getting your predicted value, which that's exactly what you do. That works. But another way to sort of write that is in this formulation here, where you take those values x1 and x2, so 3 and 2 here, and you stick this into this vector x0. And one thing I'm going to mention here is that this first element of the vector, of course, is going to be 1 because you're going to be multiplying that first part by the beta 0 or the intercept, so you would still have that 1 there. So you'll have the intercept plus your predictors, the values for your predictors of your new observation, and you multiply that by the beta coefficients. I've pulled out the 1.2, 2.5, and 3. And so when you multiply these together, you get that single value for y hat, 14.7. So I want you to do this application exercise. We're interested in predicting a chicken's weight based on their diet using the chick weights data set. This data set comes with R, so you should be able to just use it directly. And so the first thing I want you to do is fit the model of interest and extract the estimated beta coefficients. And one thing you'll notice is that the diet here, the feed that you'll be using as your predictor, your main predictor, it is a character variable. So you're going to be using what we just learned in the indicator variable section to be thinking about this particular variable and how it gets implemented in this model. So keep in mind what the referent category is and what those indicators represent. And so once you have fit this model, I want you to extract those beta coefficients, and then I want you to construct an x0, an x naught, a vector here of the predictors, where this is going to be for a new chicken that's eating a sunflower. So that's going to be one of the indicator variables is going to be that they eat sunflower. And so I want you to create this x naught vector that basically is like the one on the previous slide that I showed, where the first value is going to be 1. The subsequent values are just going to be the values for the indicators for this particular chicken, which is going to be 0 for everything except for sunflower. It'll be 1. And then I want you to find the predicted weight for a chicken that eats sunflowers using this method.